Let's understand our topic, which is fundamental theorem of arithmetics. According to this, the definition first, it says that any composite number can be expressed in the factors of prime numbers. What I am saying, for example, I have a composite number, say 4. So this 4 is a factors of 2 into 2 into 1. Basically all the factors are prime numbers. So the fundamental theorem of arithmetic says that any composite number is made of, what I am saying, it is made of prime numbers factors. Like in a simple way, we can say that all the composite numbers are the factors of prime numbers. That is, all the numbers like composite numbers, like a composite is a factors of, like I have a factors like a factor of all that is prime numbers. Like the composite number, all the composite numbers have factors prime numbers, okay, made of factors prime number. Like all the numbers, like composite number is made of prime numbers. Example, generally, for example, I have a is my composite number, so is a factors of b into prime numbers basically, or where b and is also belong from prime numbers. And the fact is that all the number, for example, I says a number 4 has a factors 2 into 2 into 1. In the 6 it has 3 into 2 into 1. In say 8 is all the prime number. What is 2 into 2 into 2? Say 10, it is 2 into 5. And similarly for 12, it is 2 into 2 into 3 into 1. Okay, so when you all these example, you see that, for example, the 4 has only one combinations, like the 4 is always written in the form of 2 into 2 into 1. Any other prime number are not using when we using the 4. For similarly for 6, the 6 is always written as the multiple of 2 into 3 into 1. And similarly for 8, like the 8 is always written in the multiple of 3 times of 2. So all these the factors can what are, like all these example, what we see that all the factors of a numbers is always like a unique way. Like all the factors of a number is a unique. All the factors of a number is unique. Unique means it has only one combination of multiplying the prime numbers and obtain the their numbers, which is the composite numbers. Okay, now we explain what is the fundamental theorem of arithmetic. It's time for our question and answers. Okay, for example, I have a questions which is random way, like we say for from small to big. First we go 20. Okay, according to fundamental theorem, let's factorize the 20 into the prime numbers. So the factors of 20, first we write the 20 in this way. So starting from lower prime number, 1 is the always multiple, so the lowest prime number is 2, so always starting from 2. Then so starting basically like for example 2, then we move for 3, then 5, like in increasing way. Okay, in increasing way we always factorize this thing, because if we not increase, like in a we massive, like all these things with the mess up and it's like not things. So good. Okay, so it is 2 2 10s are 20, again 2 5s are and 5 into 1. So all the factors of 20s are, which is 2 into 2 into 5. Okay, so you see that the combination is always 1, and we always written as 2 to the power 2 into 5. Similarly, next example is like the same 2-digit number, let's say 80. Okay, so same, we write this 80 into that way. For lowest, 2 4s are 8 0 0, again 2 2 2s are 4, 2 zeros are 0. Similarly, for 2 10s are 2 and 5s are, and similarly for 5 1s are. Okay, so now our 80 become 2 into 2 into 2, once again 1 2 3 into 4 times 2 and 5. So now we can say the 1 2 3 4, 2 to the power 4 into 5. We complete 2 digit. Now let's move to the next, what's it, 3 digit. Okay, 3 digit. First, like 100, let's do. So write 100 into this way, and simply for 2 2 5s are 2 0, 2 2 2s are 4, 2 1s are 10, and 2 5s are 10. So 2 now since now we have 25. So first we do for 2. Oh, it is not for 3, it is not. Now it's time for 5. 5 5s are and 5 1s are. I gave you some tricks, now you. Okay, so for 100 it is 2 into 2 into 5 into 5. So simply 2 to the power 2 1 2, and into 5 to the power 1 into 1, basically 2. Yeah, so these are some questions. I gave you some interesting fact, like first for 2. Okay, so if we want to like understand which number is divisible by 2, like for example here is the 20, and if for example I say 1498019 and 8. So now can you calculate this number is can divide by 2 3 4 5 6 and 7. For example you say 2, and if I say it is multiple by 8 3, can you, like, you rather you using like 3 1s are 3, 3 4s are 10, 3 like 3 4s are 12. So rather the using these complex multiplication, we use the division theorem, like all the divisibility rule. So the divisibility rule, okay, so first we decide the divisibility rule. Okay, in this video I explain for 2 and for 3, and the next video I explain for 4, then 5, then 6. Similarly for this, the interesting fact, like in all video I give you some interesting knowledge that use to summer, like useful all these tech which are good. Okay, if I came in my mind. So for 2, which is if the unit digit, like if a unit digit is the multiple of 2, multiple of 2 means is the even number 0 2 4 6 and 8. Now 10 become always 0. After that is always repeat, like for 12 this 2, for 14 again 4 repeat, 16 6 and 18 for this. Okay, so now so any divisibility rule for 2 says if the unit digit is a number of 2 0 4 6 8, then the number is always divisible by 2. Like this number is always divisible by 2. Like for 2 this become 2 7 4 9 0 9 and 9. Okay, so this is divisible by 9. For example for 3, I hope you understand. And for 3, if the sum of all the digit, sum of all digit means 1 plus 4 plus 9 plus 8 plus 0 plus 1 plus 9 and plus of 8 is a multiple of 3, then the number is divisible by 3. Okay, so it is like or not. This is for 10 10 and 10 20 20 and 12 32 and 8 become 40. So since the all the sum of digit is 40, so it is not divisible by 3. So for 2 we say unit digit is 0 2 4 6 8 for 2, and for 3 sum of all the digit is multiple of 3. Okay, these are some fact. Okay, now move our question like this. 100, the unit digit 0 multiplied by 2, 0 2. For 5 we gave some in next video similarly, and for like an example. Oh, the video getting long. Okay, so I hope you understand. If any doubt regarding this concept, fundamental theorem and the divisibility rule, write down the comment section. And it's time for a homework section. The homework section for this is okay, and I can give you some homework like similarly factorize the which we discuss in the class. You give the answer in the comment section and do by yourself. So first it is the number, question number 1. Similarly from 33 and 46 1 1 10 9 8 1. Okay, and now for upper 1 0 0 1 and at last 5 4 3 0. Okay, so 5 4 3 0. All these questions do by yourself. And question number 2, by using the unit digit concept. First it is 24, using the unit digit formula. 46 66 999, then 1 2 3 8 9 0, 4 5 5 4 9, and 1 1 1 1 and 1 1, and 1 2 3 9 8 1, 7 5 7 9 4 2 1. These are the questions. Do by yourself. Okay, and using the proper method like 2 divisible by 2 3, or if you understand the concept of 2 and 3, our next part is part 3. Build your own question. Okay, like for example I explain you the divisibility of 2, divisibility of 3, some fact of FTA, fundamental theorem arithmetic. So you build your own question, like you understand the FTA. If not, again watching, then you explain the FTA. If you understand the FTA, now you create your own. Like I also create this all questions in instant of this time. So you create all these questions like whatever you mind, like play with the numbers for the concept which I studies, which I explain. The play the numbers and build your own questions, then answer the question. If you get any type of doubt, I am here with you. Put in the comment section anywhere you want and give me the feedback. Okay, I hope you understand. If you understand, like and subscribe. Bye bye.